This is the fractal flame we are going to build today, and it's made out of 3 variations. The first one, the most important, is called Flux, and then is using a linear and a cylinder variation, which is actually responsible for generating all those yellow corn, intricate net of yellow corn going everywhere recursively. It looks very beautiful, and it's fairly simple to build. So let's go inside Houdini and do it. Before we start, let's have a look at what Xaos is. Let's go and click on this icon, and this will open the FLAM3H documentation. Let's expand the FLAM3H tab parameter, Flame iterator parameter, and let's click on iterator Xaos. Without reading, let's look at this diagram. Every circle, every gem represents an iterator with one variation each inside. What Xaos does, it will allow us to decide where each point go after that iterator executes its operation. So we will pretty much define the travel of this point across different iterators. So let's create a FLAM3H node. Here you go. Perfect. And now we go and we will clear this default setting in FLAM3H, and we will create just a few iterators. Perfect. And to start, we go to the CP tab, and now I'm loading a palette that I already created for this fractal flame. So perfect. You can load any palette. This one is just something I liked and I save it for myself for this purpose. So it has the HSV value set already. And now on the first one, we are going to create a flux variation, which is the most important. So we go down, they are in alphabetical order. Here you go, flux. And we can see it ends with 3 dots, the name flux, and it's a parametric variation. So to start with, we go to the vars tab to find this parameter and set this to 0. And we rename this iterator to flux. And then we go on the second iterator and we leave linear there, and we just make changes to the preaffine. So we invert the x value to -1 and we offset it by -0.5 on the left. Perfect. Now we're going to set the iteration number to 48 because we will need more iteration to resolve this fractal flame. Perfect. And now we go back to the flux variation and we are going to play with the spread, and we go negative, and we can see pattern are going to form. We will stop at 0.79. You can try different value. And now we're going to set the location and speed for the shader, which there are values that I already have. So this one is for the location, so we can set the color properly based on the palette. And we'll do the same for the linear. So 0.036 and .756. Perfect. Now we have to adjust the weight of each iterator. And so for the first one, we're going to set it to 0.23, and we set it higher for the flux. So 0.52. Perfect. So we are almost there. We go to the palette and increase the value of HSV to 3, so we can have a better and stronger color in the viewport. And let's try to see different spread. They're very cool pattern to find out there. And the good house cleaning help us to move with the iterator. And now we create the third iterator, and we're gonna create a cylinder variation inside it. So let's set the weight the same as the linear for this iterator, so 0.23. And now let's pick a cylinder variation. Perfect. Now it looks a little bit like a mess. I mean, I like it, but this is not what we want to do. Let's activate the post affine and scale this cylinder in X with a value of 0.23, and let's offset this by -0.25, which is exactly half of how much we have set the linear variation. Perfect. So now we have to add a little bit of pre-blur to smooth out some of those details and make it look like more of a tube. Perfect. We can see we can increase the value of the pre-blur or decrease it. Is up to you. I found out that 0.3 works best for me. Yeah, we are pretty much done, and let's set the color. Let's just move the location slider until we get this uniform yellow across all those cylinders. Oh, they look like corns. Anyway, and now let's go to, yeah, it's good to have the name so we can quickly move and know which iterator does what. Now let's go to the FF, the final X form, activate it, and just let's pick a spherical variation. Perfect. And let's play with the offset of the spherical variation for the pre-affine in the FF to make some more deformation. Very cool. And now let's go to the flux variation. Yeah. And let's play with the rotation until we get something like 3 branches or something like that. Yeah, perfect. And now we just need the one important thing, so we need to set the Xaos value for the iterator with the flux. And we want to send more point to the linear variation, so we change the second value to 20. And this means that out of 20 points, 19 now will go to the second iterator, and 2 points will go either to the first or to the third iterator. And now playing with the rotation value, we can see some nice shape there. So just pick the one you like more. It's very, very cool. Yeah, even this one. So let's stick with the kind of tree-like structure. It's very cool when they kind of get that sinusoidal shape. And we can see if we increase the iterator weight in the linear, we get more point into the center. And if we get the flux iterator weight changed, we can see we can get different results. This looks like an X-ray of a tree or something. So let's stick with 0.52, and now let's increase the point count to 15 million so we can review it better. Let's go to the preference tab and change the viewport point size to 0.4. Perfect, and it's already looking really beautiful. And now the only things left to do is to go in Karma and set up the fractal flame with a FLAM3H USD node and render it. So let's lock the property windows and let's go to stage. Let's create a FLAM3H USD node, and this will import this flame directly, deactivate the grid in the viewport, and let's click this viewport reframe so it will adjust the clipping plane also. Let's set the viewport to dark, let's use Karma CPU, and let's use the NVIDIA Optic denoiser. Very great. And now let's reduce the width after we framed it the way we like. I kind of like this framing. Let's set it to 0.25 for now. Nice. And let's give him more point. In my case, I'm gonna set 50 million point. This use 48 iteration, and we will wait like about 9-10 seconds on this machine. Nice. Maybe let's increase the width a little bit, like 0.35, so to pop up a little more, and that's pretty much it. It's done. Like a flux linear cylinder flame completed. It looks really cool.